Okay, I think it's good to you know talk about a bit more technical topic here.
Yeah.
Let's see how we can make it alive. No, I just think just to set the scene, I think we talked about it briefly last time around during the discussion, about microgrids in particular, but smart grids not so much. But when I think about energy transition, it's most of the companies talk about this three Ds, 3D as a strategy, decarbonization, decentralization, and the last piece, which is the digitalization, is perhaps a very overlooked topic, right? But it is an important piece as well, the digitalization, and it pertains to some element of the energy chain or the power chain, which is perhaps a bit more regulated, if I may say, which means the transmission and the distribution side of the business. I think it is important to also understand how we can digitalize the networks to enable this energy transition, the clean energy transition, especially since there is increasing decentralization of the energy that is happening, which means that, and that's one, and then there is the second, the increasing renewable energy penetration that's happening, all of which is posing serious challenges to the grid operators. And the third element, of course, is the extreme weather conditions. I think we've seen it in Texas a while back as well. So if you think about decentralization, the increasing renewable penetration and extreme weather conditions, all of it put together poses serious challenges on the grid operators, the transmission and even distribution. So in this context, how can a smart grid, how can you make a grid smart enough to achieve these goals and enable the energy transition? That is, in a nutshell, what would be interesting to discuss. So I'll open the floor. Maybe Sarai and Suvendu, would be interesting to hear your thoughts on these topics. How can we make the grid smart enough to cover these topics or cover these challenges while also helping transition into a clean energy landscape?
Thanks, Suresh. Yeah. I'd like to start with explaining the problem at the outset. So, why are we even discussing the smart grid and microgrid? We want to see what is the problem with legacy grid. So, the legacy grid, as we know, has been there for the longest period of time. So this was when you had big, large-scale utility generators, the 250 megawatt to 500 megawatt units connected together to a high-voltage grid and supplying to the consumers and stepping it down to the lower voltage for the consumers. And that was like a one-way system. So in that aspect, the grid, the big generators don't care what the consumer wants. They do, but they don't have any feedback from the consumers. The feedback is basically through frequency. So when the frequency goes down, they increase the generation. When the frequency goes up, they reduce the generation. So it's a demand management rather than, let's say, forecasting or anything like that. So the next step or the obvious step would be to have a two-way communication. That's where what you said, Suresh, regarding the digitalization, what comes in,
Correct.
the smart metering and all those things, where what is the demand, and then you predict the demands, like demand forecasting. Then as renewables come in, so that's actually the biggest game changer. Instead of the large utilities, now you have smaller units like 1 megawatt, 5 megawatt, 10 megawatt units coming into the grid, feeding from the bottom, reducing the load. So it creates a lot of instability in the grid. And to avoid that or to tide over that issue, the smart grid concept is basically looking at both ends, your generation and your consumption, and then try to balance them in a much more better way by digitalization, where you have smart metering, you have better storage units, the renewable generation forecasting. But that aside, microgrid is actually the concept which actually can take the whole renewable energy to the masses, in the sense that legacy grid and smart grid are almost there in almost all the developed markets. But when you're looking at developing markets, where like last week when we discussed about accessibility to energy, most of the developing economies, there are places where you don't have high voltage lines or substations available. This is
Correct.
why a microgrid comes in. So microgrid is basically an independent grid which has a set of small renewable sources or non-renewable sources, but all connected to a small village or town, or a small regional area, where you're supplying the power to local consumers. It could be connected to a main grid, but need not be connected. So I think that is the way the three grids will work. So
Correct.
microgrid can be supporting the smart grid. Um, Microgrid can be also smart, but it can work independently, where in remote
Sure.
areas and can be connected back.
Sure. So
Yeah,
that's important to set the definition, right? So smart grid, I
yeah,
mean, microgrids is something which powers a community, perhaps off the main grid independently. Sometimes you can have connection to the main grid in a smart way, but the smart grid itself is a grid. I mean, there was a question from Anand that is a very relevant question, maybe to clarify. So smart grid, as Sarai mentioned a while back, the grid, traditionally, the electricity in the grid flows in one direction from the generator to the consumer. It transmits through the transmission network to the distribution network and to the final consumers. But a smart grid is which allows, basically, in a simple terms, bidirectional flows, meaning it could flow from a generator to the consumer, but with increasing decentralization, even the consumers could, in a decentralized way, power the grid through various tools. And there are various tools which allows this. There are software that allows it. And when we talk about smart grids, that's one element of that. Making the grid smart. But there are many other ways to make the grid smart by improving the operational efficiencies of the grid itself using cloud computing, artificial intelligence, implementing smart meters, and so on and so forth. So all of it contributes to the digitalization of the grid, which make the grid a smart grid. Suvendu, I think India had a massive rollout on the smart metering. I mean, there's a lot of debate on whether it's efficient enough or not, or just smart metering itself is the end goal, or is sufficient to make the Indian grid, support the decentralization and renewable penetration. What's your view on that?
Yeah, thanks, Suresh. In fact, in 2012, I guess there was a India Smart Grid Task Force was been set up, and they have selected, I think, 100 plus cities where they want to integrate and to basically the normal grid network has to be upgraded to the smart grid system, and the basic starting point is, of course, the smart metering system, which
Mm,
in fact, the state of Chhattisgarh, per se, is one of the most developed state. Of course, we talk in terms of remoteness of maybe it's a little backward that way people used to mention, but on the electrical network, it's one of the most smartest grid. And
mm,
the smart metering integration has already been at many of the locations. They are already pioneering that. Having said that, to add up to Sarai also, a smart grid system, there is, as you mentioned, there is a bi-directional flow of information. It starts with automatic metering, which is the basic of any smart grid system, and of course integrating the say decentralized generation of power through wind or basically solar into the main grid, so that the pattern of power generation could be understood, and accordingly the dynamic management of power consumption versus demand could be done. So
mm,
yeah, that,
mm.
that is, and even the power quality also you can maintain. You can predict the demand. So I think these are the factors that make up the smart grid.
Yep. No, it's an interesting thought process. Just to give a bit more context to it. I mean, Sarah, you are in UK, so I think I've come across some recent news article about one of the energy retailer. I mean, energy retailer is a company which exists in deregulated market, which allows which can supply to the consumer, just like a telephone company could be. And the difference being the energy retailer may not even own the assets or what the wires even, they can buy the power from the exchange and then supply to the consumers. But there is an energy retailer I heard in UK who is incentivizing uh, EV owners to use the capacity in the battery of their electric vehicles as a aggregator or a kind of virtual power plant aggregator, meaning that those capacities could be made available to the grid for various purposes of grid balancing and other features. And interestingly enough, the many Nissan Leaf is one of the cars which allows this kind of bidirectional charging, meaning it allows to draw power from the grid and also inject power back into the grid. So bidirectional charging. And many of these retailers world over, wherever there is a deregulated market, they are rolling out these bidirectional chargers. There are policy measures implemented in Europe, in Germany, or car manufacturers are getting together to create standard protocol, etc. So on this context, the regulatory scene is also an important factor, right? Because in as you rightly said, Sarai, in many of the traditional markets like India and all, there is no actual incentive to do spend on the OPEX elements. There is a lot of incentive to do the CAPEX, capital expenditure, by drawing new lines in which the transmission company can earn return on the regulatory asset base, which promotes capital spending, but not so much on the software spending of the business, which is more an OPEX. So unless there is an efficiency incentive mechanism which is introduced, can't see how the grids, traditional grids like in India, or for that matter, unless there is a change in regulation, how digitalization can be rolled out at a large scale.
Suresh, interesting point because you're probably talking about Octopus Energy, which is in the UK, which is actually supplying my home also. So they are one of the energy retailers who supply renewable energy because their mix, they buy from renewable energy sources and they supply to homes. So they have they have smart metering. Yeah, of course, here in the UK, you have almost a good smart metering system. But as you said, the technology that you're talking about is the vehicle to grid technology, which Nissan Leaf have integrated. So what they do is Octopus, and if you have a deal with Octopus Energy or a supplier who does that sort of thing, your system manages your charging of the car during daytime, and at night it can
Correct.
be used as a battery bank. It need not be supplying back to the grid all the time, but it's there on standby. So if you
Correct.
need like a grid support, so I think there's a couple of other companies who have come in for enhanced sort of battery storage systems, which have been put in last year in October, where they have put in like a 300 megawatt couple of battery units. And these battery units have been actually called in to service last year 3 times already. So where they discharge the whole battery in like a half an hour's time to supply the grid stability. So, but
Correct.
other than that, they do generally supply the grid with stability by continuously charging and discharging. But the vehicle to grid is a wonderful concept. This was always talked about in the early days of smart grid, and it's coming to reality now. With vehicle manufacturers integrating this sort of systems in the vehicles in EVs to actually facilitate this function. And so they are working with these sort of energy retailers to create a product that basically, so when your electricity bill comes for the next month, you will see how much you have actually put in back to the grid, and you get credit for that. You are
Correct.
incentive, you are given a
True.
reduced rate, but you do get money back on
True.
your bill. Yeah.
True. Yeah.
So one
No, I
point.
think there's a question from Srideep. Sorry, Suvendu. I just want to address it because it's
Yeah.
relevant to what Sarai was saying. I think the question is, does it? Okay, I think there was an earlier question in terms of what needs to be changed. Is there a retail energy supply market essential for smart grid rollout? Not necessarily, Srideep, because the retail market itself would help to create business models like what Sarai just now said, which is basically a kind of virtual power plant where you aggregate idle capacity, be it in from a car which is fully charged, or for that matter, any battery which is sitting ready to connect to the grid. But that in itself is not the issue. But the issue is the incentive mechanism for the grid operator, because in many markets, what is happening is the grid operator is incentivized based on a regulated return on the regulatory asset base, which is quite capital intensive. So there is no efficiency for operational excellence. So unless the incentive mechanism changes to incentivize the grid operators for operational efficiencies, there won't be enough software deployment or software spend on these matters. So which makes the grid smarter, because typically the grid operators don't want to spend on the OPEX and would rather focus on the CAPEX. And that's regulatory switch also is needed. So Suvendu, you were sorry to interrupt.
No problem, Suresh. Just to add to Sarai and your point also, in India for the solar sector also, the excess energy that has been generated if the captive load demand is not there in the daytime. So there is a mechanism known as banking. So
Right.
that's the way you can bank the power with the discom and utility. There would be some banking charges that would be levied, but yeah, during the peak hours, you can, if you have excess generation, you can bank and you can take during the off-peak hours. So that facility, of course, is part of microgrid and smart grid. That's already been is implemented, and in the open access, maybe a little technical term, but in the large power generation, generally this policy has already been driven in at least in the solar sector in India.
Yeah, so that's important. Banking arrangement is also good, but it's in a way similar kind of tools or mechanisms like demand response system, right? I think demand response system is a way by which the utilities, the grid operator could incentivize the major consumers who has flexible demand to push their power consumption to off-peak hours by achieving balancing. So there are, again, it comes to the regulatory space. So if the model, revenue model works for the grid operators, and if they are incentivized enough to roll out these kind of mechanism, then of course we have seen that in markets where such regulatory mechanisms are in place where these kind of things are happening. Virtual power plant is a wonderful idea. I think it will come more and more, perhaps even in India at some point in time, because if you have a grid with so much renewable penetration, ideally you will have a lot of battery storage that you need to keep for balancing the grid. And when you have battery storage integrated into the grid, not all these batteries are sitting idle most of the time. So there are multiple ways to use it, provided there is a remuneration mechanism for this, be it in terms of grid ancillary charges and so on and so forth. But without going into too much technical detail, I think I also want to talk about the grid efficiencies, how it can be improved too, using artificial intelligence or cloud-based computing, which is also happening, given the fact that there are a lot of distributed energy resources that is being integrated. Any thoughts on that, Sarai or Suvendu?
Yeah. I think and efficiency is a key point because on legacy grids, where your generation is concentrated in areas like take for example in India, usually the generation used to concentrate around the coal belt of India, which in Chhattisgarh, Bihar, Eastern UP, and all those areas where you have all these big power stations. So when you think about evacuating all that power to the consumers, you are sending it across huge HV lines, and the transmission or the efficiency or the losses is significant actually. So when you distribute that generation and distribution to, let's say, microgrids and all those things, it improves the efficiency because you are closer to the consumer. The generation is closer to the consumer, so it's like very like enabler for efficiency. So just touching upon that last point regarding vehicle to grid sort of thing also, Suresh, it's a topic that we can discuss on another session. It's
Correct.
a
I think
very, very interesting topic. Yeah. So
it warrants
let's,
a discussion on its own.
yeah, separate. Yeah.
Yeah.
Separately, indeed. I think we
Yeah.
could talk about it. But your
Yeah.
point about the fact that traditionally the coal-based plants in India has been in that Madhya Pradesh, Chhattisgarh belt. It's repeating itself on the renewable side as well. Because if you see the solar power plants, most of them are in the belt of Punjab, Rajasthan, a little bit on the UP side, MP for that matter. And when we talk about wind, it's mostly in the Gujarat and Tamil Nadu, given the wind flow. So my guess is unless we have a regulatory change on the transmission side, which incentivizes deployment of software, we will end up with same kind of bottlenecks as we would have in the earlier days, but which will require massive capital spending. But we should find a smarter way to de-bottleneck that transmission network through software because the technology is readily available in today's world. Suvendu, anything
Yeah.
to add on that?
Absolutely. No, I, I can only add on the point